124 from PreCalculus OpenStax. You're given a function and asked to find not just the domain, but the domain and the range. We've covered domain in some previous examples, but I'll talk about it since we're here. For the domain, I don't see any square roots or really any even roots going on here, so I don't have to worry about that domain rule. But I got to make sure I don't divide by 0. So what's going to make me divide by 0? If the denominator equals 0. So x plus 1 equaling 0 would be something that's not in my domain. In other words, x cannot equal negative 1. My domain is all x values except for negative 1. If I were to write that in interval notation, I could say it's everything from negative infinity all the way up to negative 1, union everything from negative 1 up to infinity. You're like, wait a minute, it sounds like you just talked about every number. I didn't talk about negative 1. Because these are parentheses, I'm not including it in this set. And because these are parentheses, I'm not including it in this set or this interval. So it's not included in any one. It's almost every number except for negative 1. That's the domain. Range. Okay, if you're in my class, I'm not going to ask you to find the range of a function when it's written like this. Because it's really hard to do, frankly. I mean, some functions, maybe if you have a pretty good idea of the graph of the function, you can figure it out this way. Realistically, if I were asked to figure out this range, that might be the best method to go, is to graph this thing. It turns out that the range is all numbers except for 0. What can come out of this machine is all numbers except for 0. The reason I wanted to do this example is because I wanted to talk through that and maybe reassure you that that's pretty damn hard to figure out. First of all, why is 0 not in the range? Well, there's no number you can divide 2 by to make it equal to 0. There's nothing the denominator here can be to make the entire thing equal to 0. You're like, what if the denominator is 0? The denominator can't be 0, right? 2 divided by 0 is undefined. Negative 1 is not in my domain, so I am never putting negative 1 into this machine, so I don't have to worry about that. But it's not equal to 0 anyways. There's no number you can divide 2 by and make the answer equal to 0. Think about it. 2 divided by 2? No, that's 1. 2 divided by negative 2? No. 2 divided by 1/2? No. There's nothing you can do. There's nothing you can divide a number like 2 by to make it equal to 0. So that's why 0 is not in here. But every other number is. That's true. I'm not quite sure how I'd convince you of that. I mean, if you want to pick a number, what about 1/8? I could find the input that would give me 1/8 of as the output. I could set this output equal to 1/8 and solve algebraically to figure out what I would need. I think it would be 15 in that case if you're curious. But that doesn't tell me that any output can come out of this. How do I know that any output other than 0 can come out of this? And frankly, I don't. I mean, I guess you can just kind of talk yourself into it. We'll learn ways to figure that out later on. I think using inverse functions will be the easiest way, although you can also use function transformations. But for now, you just kind of have to believe, I guess, which is why I don't think this is a great problem. However, there's my 2 cents on it. There's example 24. I'll stop complaining.